This video will cover part 2 of Pre-Calc Notes 2.3. We left off talking about synthetic division and the way that we can use it to help us factor polynomials or to divide a binomial into a polynomial. Another use for synthetic division is using that to figure out the value. If I know what x is, I can find what g of x is. So if I know that x is equal to 2, I can use synthetic division to figure out what g of x is. In the past, what we would do is, if I told you that find g of 2, you would do 2 to the 6th power minus 4 times 2 to the 4th power plus 3 times 2 squared plus 2. And that would certainly give you the right answer. But again, I want to show you how to use synthetic division to get this same result. So what I can do if I'm going to use synthetic division is I'll put the 2 on the outside here, and then I will list out all my coefficients like I usually do, but again I will recognize if I'm missing anything. In this case I go from an exponent of 6 to 4. I have to represent a 0 for the x to the 5th power. I also have to represent a 0 for the x to the 3rd power. And then also here I have to represent a 0 for the x term that's missing. So when I list out my coefficients, I'm going to start with a 1, then I'm going to put a 0 for the x to the 5th term that's not there, then a negative 4, and then a 0 because there's no x to the 3rd, then a 3, and then a 0 because there's no x term, and then a 2. And now I can do synthetic division, and whenever I get for this answer right here, that would be the exact same answer I'd get had I plugged this into the calculator and get my answer. So my answer is really the remainder in this case. So remember, we start synthetic division by bringing down the first term and multiplying on the diagonal, adding vertically. So add that, I get 2, multiply, I get 4, add, I get 0, multiply, I get 0, adding, I get 0, multiplying, I get 0, adding, I get 3, multiply, I get 6, add, I get 6, and multiply, I get 12. Finally, to add that, I would get 14. Like I said, had I taken the time to punch this into the calculator, I would also get 14. So the answer to this problem is really 14. Again, the answer would be whatever the remainder is. Doing again when we get have a negative 4, you'd list out your same coefficients, but you put a negative 4 over to the side here. You'd list out the coefficients of 1, 0, negative 4, 0, 3, 0, and 2. And then you drop them down. So it'd be 1, negative 4 when I multiply, add would be negative 4, multiply would be 16, add would be 12, multiply would be negative 48, add would be negative 48 also. Multiplying here, I'm going to get a positive 192. When I add, I get 195. When I multiply there, I get negative 780. Adding, I would get negative 780 again. And then multiplying, I would end up with 3,120. I should have extended this line over a little bit. And now my remainder, when I actually add those together, gives me 3,122. And so that would be the answer. Had I taken the time to plug in a negative 4, raise it to the 6th power, minus 4 times 6, times negative 4 to the 4th power plus 3 times negative 4 squared plus 2, I would get 3,122. Now you may be thinking while you're watching this, isn't it going to be much quicker for me to go through and type this into my calculator to get 3,122? Yeah, probably with an example like this, it definitely would be. This is just to get you used to, again, seeing the synthetic division process, and also understanding that there are multiple correct ways to solve these problems. But one of the important reasons also that I've included an example like this is so you really make sure when you're listing out your coefficients for synthetic division that anytime you're missing an exponent, you add those zeros in. And we had to actually do that in 3 different places in our problem. So if you would rather do, just type it into the calculator, replacing the, the x of the 2 or the x of the negative 4, I'm okay with that. But you do need to know the synthetic division process to do, our next example, or even to do examples in the previous section of the notes as well. Alright, our last problem for the notes says to use synthetic division to show that x is a solution to the equation. So they already give me a 0, so I'm actually just going to put that on my line already because I know that that's going to be an answer. I should have 3 answers altogether because I've got a degree 3 polynomial, which hopefully means that I should have 3 factors as well. So I want to factor and find all the zeros of this polynomial. Now notice that if I'm given the 0, when I do synthetic division, I can put the negative 4 right out here. If I'm given this as a factor, I have to actually set it equal to 0 and solve. But if you are given the 0, you list that right out over to the side here. You don't take the time to set it equal to 0 and solve. You only do that when you're dividing. And then we want to go through and list out our coefficients. So our first one is x to the third, which is a coefficient of 1. Then notice I'm missing the x squared term. So I've got to add a 0, then negative 28, and then negative 48. Now, if this is a 0, it means when I go through and I do synthetic division, I should get a remainder of 0. If I don't get that remainder of 0, I know that I didn't do my synthetic division right. So let's check it to see if I do get that. So drop down the 1, multiply it's negative 4, add, it's also negative 4, multiply it's 16, add it's negative 12, multiply it is 48. And so when I do add those together, I get 0, and that's what I wanted. So again, remember how we start this off. If this was a degree 3 and x to the third, that means that this problem has to start off, since I divided out just one x, has to start out as an x squared. So this would be 1x squared minus 4x minus 12. And what I want to do is I want to solve this by factoring it. So the way that I factor this is I ask myself what multiplies to be negative 12 and adds to be negative 4. And so I'm thinking 6 and a 2, where the 6 has to be negative. And that way this is going to break down then to be x minus 6 and x plus 2. So I'm going to stop right there because that gives me my 2 factors, x minus 6 and x plus 2. But remember I said I should have 3 factors? So the way that I'm going to get my third factor, when you're given a 0, if you want to write this as a factor, what you have to do is you have to take whatever the 0 is and do x minus that. So you have to do x minus the 0. This particular problem has a 0 of negative 4, so if I do x minus negative 4, I really get x plus 4. And now that's the factor. So I can write it down here as the 0 of negative 4, but when I write it over here, I want to write it as x plus 4, because that's my factor. So these would be my 3 factors. I already have one of the zeros because they gave it to me. And the way that I find the other 2 zeros is I set my factors equal to 0. So x minus 6 equals 0 gives me a value of 6 as a 0. And x plus 2 equal to 0 would give me a negative 2. And so now, again, I had a degree 3 polynomial, I've got 3 factors, I've got 3 zeros. So it's always good to stop and check to make sure that you have that. Now, you're not always going to get 3 factors if it's degree 3, but most of the time you should. And this is an example of where I do get all 3.